So today we're going to cover section 4. Today we're going to learn some new properties that you're going to need to memorize because we're going to be using them in our algebra proofs as well as in our geometry proofs. So the first are 4 properties of equality, and you're probably familiar with these because you've been using these 4 properties to solve algebraic equations. So the first one is called the addition property of equality. And what you're going to be doing here is if A equals B and C equals D, then A plus C is equal to B plus D. And then the subtraction property of equality again says if A equals B and C equals D, then A minus C is equal to B minus D. And basically all you're saying here is if you subtract the same number from both sides of the equation stays the same. It stays equal. Then the multiplication property, if A equals B, then A times C equals B times C. And this C with the equal sign with the slash means C cannot equal 0 because remember anything times 0 is 0. And then the last one listed here is the division property of equality. And again, if A equals B, then A divided by C is the same as B divided by C. And again, C cannot equal 0 because anything divided by 0 is undefined. Now I'm going to give you examples of all 4 of these properties, and you're going to be able to recognize what they do. So for the first one, for the addition property, so this is an example of the addition. And I like to abbreviate property of equality as POE. So this is an example of the addition property of equality. When you would use something like this, you would be given a subtraction equation. And then to use the addition property of equality, what we're doing to solve for x is adding the same number to both sides of the equal sign. Once we do that, we end up with x equals 7. This is an example of using the addition property of equality. We're keeping our equation balanced. Whatever I add to the left side, I'm also adding to the right. The next property, the subtraction property of equality, what we're going to do here is, and again, property of equality, so I abbreviate it as POE. You'll be given an addition equation. So let's change that sign now to an addition sign. And now to solve this, we're going to subtract the same number from both sides, which gives us x equals 3. And this is an application of the subtraction property of equality. Next, we'll do the multiplication. So the multiplication property of equality, you're going to be given a division equation. So for example, x divided by 2, and you're going to see division written as fractions, equals 3. That's your given equation. And now to solve for x, we need to multiply both sides by 2. It'll cancel the 2 out of the bottom of the fraction, and now you're just left with x equals 6. This is an application of the multiplication property of equality. And now lastly, division property of equality. And again, you'll be given a multiplication equation. So let's say it's 2x equals 6. Again, to solve for x, we're going to divide both sides of our equation by the same number, and it's the number in front of x. And we end up with x equals 3. So when we use these properties of equality, whatever you're adding, subtracting, or multiplying or dividing to the left side of the equal sign, you need to do exactly the same thing to the right side. So the next property is called the substitution property. And this property states that if A equals B, then either A or B may be substituted for the other in any equation or inequality. So for example, if they give the equation, if 2A equals 10, then 2B also equals 10 because they told us from the very beginning that A and B were equal. So it wouldn't have mattered if I put in the A or the B into either one, I can substitute it. Another way that you may see the property of substitution explained or used is, let's say they give you an expression. Let's say they tell you it's x plus 3, and they're going to say, they'll say evaluate given if x equals 2. So they'll say evaluate if x equals 2. So then what they would want you to do is take what x equals, substitute it in, and then do 2 plus 3, and then you can evaluate it, and it equals 5. So what you're doing is replacing something with something else that you know that it's equivalent to. The next property is called the reflexive property. I think of this as like a reflection. So when you look in a mirror, you see yourself. Here, reflexive property is just the same thing equals the same thing. So A equals A. Could be a number. It could be 5 equals 5. It's just the same thing equals the same thing. We will be using the reflexive property quite often when we start doing triangle proofs and quadrilateral proofs. The next property is called the symmetric property, and this just states that if A equals B, then B equals A, sort of like a line of symmetry. Or you could also think it's similar to the commutative property, where the order switches. But if you want to think of this as like a line of symmetry, you could draw your line through the word then, and then what's going to match up is the B's match. If you were to fold it up, then the equal signs, and then the A's. Sort of like a butterfly. So if you fold up the wings across the body, the wings of a butterfly are symmetric. So this is similar to symmetry. The next one is called the transitive property. And this is similar to our law syllogism. So if A equals B and B equals C, then A equals C. So the middle part blends together. So notice these B's here, they sort of cancel out because both A and C are equal to B. So then you can conclude that A is also equal to C. Let me show you with some numbers. So let me just give you an example of the transitive. So for example, let's say they told you if A equals 3 and 3 equals B, then you can say that A equals B because they both equal 3. Notice these 3's blend together, and then you can go right to A and B being equal. And then the last two are the same. It's the distributive property. And what's in the parentheses could either be an addition sign, so it'd be the distributive property over addition, or it could be a subtraction sign in there, and it would be the distributive property over subtraction. It'll be a difference. I don't care about including the word subtract or addition or sum or difference. All I want you to do is when you're identifying the distributive property, just tell me it's distributive. So remember, when you do distributive property, what you're doing is you're taking the number outside of the parentheses and distributing it or multiplying it to both of the terms inside. So A times B gives you AB, and then A times C gives you AC. And the original sign in there was an addition, so that's what's joining these two products. And if it were a subtraction, like the next example, you're still distributing A times B, A times C, but notice what changed was the sign in between. Now, all of these properties that we just discussed can also, in addition to being applied to algebra, you can also apply them to geometry. And that's what we're going to see on the next slide. So again, all of these properties can now also be applied to angles and segments. Now I know on my slide it's kind of hard to read. Your slides is a little bit better. But this first box up here, this is the word reflexive property. And then these are all the properties that are listed under this column. This column are examples of application to segments. And these are examples of angles. So remember, your reflexive property, when it was algebra, it was just, for example, 5 equals 5 or x equals x. That was algebra. Now, when it's segments, the example here was segment DE equals segment DE, or it could be segment AB, and you could put the bar on top, but generally when you're talking about the segments being equal, you don't need to include the bar. And then here, angle D equals angle D. You don't have to necessarily write out the word angle. You could use the little symbol. And that may start paying off when you start using these symbols, because some of the proofs are going to get kind of wordy. So if you can use some of these symbols, it will definitely simplify things. And then your symmetric property of equality. This is where if DE equals FG, then FG equals DE. Notice it's like the line of symmetry. So you could draw it here, the FG's match, and then if I put the DE up here, it makes it a little bit easier to see. And then the DEs would match, as well as the equal signs. So like a line of symmetry, or just know you're switching the order. And then
can you please send Jordana Thomas to
also apply these to angles. So again, if you'd rather use the angle symbol, so you could write if angle A equals angle B, then, and then you switch it, angle B equals angle A. So you just switch the order. And then the transitive, this is, remember, it's like the syllogism, where this middle part, the C and the CD and the CD will cancel out. And then you can just go right to the conclusion that AB equals EF. If it's a segment, same thing if it's an angle. Let me go ahead and draw a picture representing this segments right here. So let me draw my segment here. I'm going to start at A and then F. And then we've got B, C, D, E, and then F. So in the explanation there, it says if AB, so AB is here, if that is equal, that one's equal to CD. So I got the same little congruency mark. And then it also says that CD equals EF. So CD is here and EF is here. So these are also equal. But if you notice this little piece right here, I've got two of the same markings here. So right here, this is like the overlap. So then you can conclude, since they're both equal to CD, then that tells you that these two would also be equal. So AB equals EF. Let me add some numbers here. So let's say I told you AB was 3. So since it's equal to CD, that one's also 3. But then you were also told that CD equals EF. So if this one's 3, then this one's 3. So that's how you can apply this using that transitive property. In the homework tonight, questions 12 through 19. This is what you're doing. You are identifying the property. You do not need to show work for 12 through 19. So no work, because all you're doing is dragging the property into the box. However, for questions, and I'll just tell you about this now before we get there, for questions number 1 through 11, so numbers 1 through 11, and number 20, you must show work to get full credit. 1 through 11 is what I'm going to show you on the next slide. You are going to be writing algebra proofs for numbers 1 through 11. Number 20 is a word problem. I want to see the work for it. But as far as identifying the properties for any of these statements they give you, you're just going to write in the property. If you want to write, let's say question number 12 was the number 1 here, then you would just put number 12 is symmetric. Okay, so that's all you're doing on 12 through 19 is identifying the property. However, 1 through 11, you are handwriting the proofs. Do not just screenshot the question and fill in the boxes. I want to see it handwritten, and I'm going to show you what I mean on the next slide. But let's go ahead and do these 4 examples first. So the first one, it wants us to justify each statement with a property from algebra or a property of congruence. Now, it's not congruence. We're going to change that word. That's a typo. It should be equality. We haven't learned the properties of congruence yet. That's coming up. So equality is what we just talked about. So if AB equals CD, then CD equals AB. Notice the order has switched here, making this the symmetric property of equality. And again, you could abbreviate POE as property of equality. If you just tell me symmetric, I will accept that. Then the next one, notice they've taken that 3 and they have distributed it to the X and the Y. So this is the distributive property. And then the next one, it says that if 2A plus B equals 24, and if B equals 4A, then 2A plus 4A equals 24. Notice what they've done is they've taken what B equals, which is 2A, and they've taken out the B and replaced it with what B equals, which is 4A. So this would be an example of substitution, because they substituted 4A for the B. So this is substitution. And then the last one, what you're trying to do is look to see, given this, what did they do to make it X equals 36? And if you notice, what they did was they used their multiplication property of equality. They multiplied both sides by 3, and they got the X equals 36. So this is an example of the multiplication property of equality. So for the substitution, so here's number 3 again. So if they're giving us if 2A plus B equals 24, and they also gave us that B equals 4A. So what they wanted us to do was take what B equals, this B right here, and we're going to replace it with the 4A. So then the new number sentence is now, instead, it's 2A, and then they took out the B, put 4A in there, and then that's the then. Okay, so notice the instructions just say justify each step. So when you see this in the homework tonight, what I want you to do is I want you to turn this solving process into a 2-column proof. So on your notability file or on your paper, however you're doing your homework, you're going to make 2 columns. The first column is called the statements. And basically, it's going to be the algebra it takes to get to be what X equals. Over here, these are going to be the reasons or your justification, which they're going to be the properties. So I'm going to go ahead and number my steps here. So 1, 2, 3, 4, and 5. Now, the first step in an algebra proof is going to be to list the problem that I'm giving you to solve. So this first statement is the algebraic equation that I'm asking you to solve for. So this is the given problem. Now we have to describe what did they do when they went from step 1 to step 2. What did they do to 1 to make it look like 2? And notice what they did here was they multiplied both sides by 3. to get it to look like statement number 3. Now, you don't have to show this red. So what they did here to the first statement is they times it by 3. Timesing it by 3 canceled the fraction, and that's how they got it to be the 2x. And then here they just put the 3 in the parentheses. So this is this reason or justification. Since I multiplied both sides by 3, this is the multiplication property of equality. Next, we have to figure out what did they do from step number 2 to make it look like step number 3. And notice what they did. They took the 3 and they distributed it to the 9 and to the -4. And that's how they got step 3. So step from 2 to 3, distributive. And now, what did they do to go from step 3 to 4? It looks like they added 12x to both sides. And this step 4 is going to be addition, property of equality. Now, you don't need to show the red, but if it helps you to see what's happening in between the transitions, you can. And then the last one from 4 to 5. It looked like they divided both sides by 14. So this will be the division property of equality. So for these algebra proofs, you've been solving equations all along and finding the values of the variables. You just didn't have to describe what property you were using. Now, when you're doing these proofs on the test next Tuesday, I'm not going to give you the statements. You're going to have to write the whole thing yourself, which is what we're going to see on the next example. So when you're doing this, if you blank out, always at least get this first statement in there and that first reason. It's worth points just by writing the problem and telling me that it was given to you. Okay? It's worth something. So let's try writing a whole thing ourselves. Now, in the homework tonight, I know it's drag and drop, but I still want you to, in your notability, make this little T and then rewrite everything. Don't just fill it in the boxes. Okay, this is what you're doing for 1 through 11. Let's try the next one. Notice nothing's given to us, so we're going to set up our little T thing. So statements on the left, reasons on the right, and then set it up like that. So again, statement number 1 is the problem they're asking us to solve. So that's all we do is take that, fill it in, and the reason it was given to us to solve. Always at least get this much on your paper when you're taking the test and I give you a proof. This particular equation, you could either choose to start moving your variables first or your constants. So your second step could be different depending on what you choose to move first. I'm going to move my variables. I'm going to get the x's on the left and the constants on the right. So what I'm going to do here is, and you don't need to show this red, but if it helps you, I'm going to add 4x to both sides. So my statement number 2 is going to be the result of that, which is 3x plus 4x is 7x plus 2 equals 23. And what I just did was the addition property of equality because I added the same thing to both sides of my equal sign. I need to work on solving for x. So I need to get x by itself. So my next step is going to be to get the constants on the right side. So again, just a visual for myself. What I'm doing is subtracting 2 from the left side of the equal sign and the right. So my new statement is going to be 7x equals 21. And notice what I did was I subtracted the same number from both sides. So this is the subtraction property of equality. And then finally, my last step is going to be to divide by 7. So to go from 3 to 4, after I divide, I get x equals 3. And that is the division property of equality. So let me do the exact same problem. So I'm going to, again, set up my 2 columns. So statements and reasons. So again, first one is always the problem. So it's 3x plus 2 equals 23 minus 4x. And this was given to me. So let's say you want to include what I wrote in red as a step. So if you do that, my next statement is going to be 3x plus 2. But then in my statement, I'm going to show plus 4x on this side. And then over here, 23 minus 4x. And then it also has the 4x there. So then this is still, you're saying addition, property of equality. But now step 3 is going to be combine like terms or simplify. So then now we would go to the 7x plus 2 equals 23. And then this reason is going to be simplify. Or another valid reason would be combine like terms, because I combined 3x and 4x. You wouldn't say addition because we're just combining like terms. So this is an alternate way to do this. Now, in step 4, instead of showing the minus 2 underneath, I put it in the problem. So 7x plus 2, and then I show minus 2, and then 23 minus 2, and I'm putting it in as a step. So again, subtraction. Property of equality. And then the next one would be subtracting that 2 and getting it to the 7x equals 21. And again, this would be simplify. So you're adding in the extra step because you're showing the red as a step. But you don't have to. You could do it the way I showed you the first way. And then lastly would be to show that you're going to do 7x. And you could either do it as divide by 7 like this, or you could write it as divide by 7 as a fraction. Either way, so this would be division property of equality. And then the last one would be simplify, because it's x equals 3. So on the test, you can do it in the 4-step way and not include these 3 other simplifies in between. It's up to you. Questions 1 through 11. I want to see you set up the 2 columns and rewrite it. I know some people are going to screenshot the problem, but I don't want you to just fill in the little box, because on the test next Tuesday, I'm not giving you little boxes to fill in. It's just going to be the problem just like this, and you're going to have to set up the 2 columns. So I want you to practice it in the homework tonight. Let's try another one. This is still an Algebra 1 skill, but now instead of getting a value for r, it's going to be in terms of the other variables. In Algebra 1, they probably called this lesson solving literal equations or something to that effect. So what we're doing here is taking our equation and getting r all by itself. So let's set up our 2 columns, statements, reasons. Step number 1 is the problem they're giving us to solve. And the reason is it was given to us. So our goal here is to get the r that's in the equation, this thing right here, all by itself. So I need to get the p away from it and that 1 away from it. So I'm using my Algebra 1 skills. Step number 1, I'm going to distribute. So I'm going to distribute the p to the r and then the p to the 1. And really that's just going to be a p. I don't have to put p times 1 equals n. And this was distributive. Again, my goal is to get this r by itself. So I need to get rid of those p's. So the next thing I can do is subtract p from both sides. So what I'm really doing here is this, and you don't need to show that in the proof, just the final of what you got when you subtracted. So now I have PR equals n minus p. So this was the subtraction property of equality. And then now lastly, to get r by itself, all I'm going to do is divide both sides by p. So my final step is r is equal to n minus p divided by p. And this is the division property of equality. Those p's do not cancel. You're going to leave it just like that. All right. So here it says you reflect the beam of a spotlight off a mirror lying flat on a stage, as shown. Determine whether the measure of angle DBA, and DBA is right here, is equal to the measure of EBC. And EBC is right here. So this is what we're trying to prove. What was given to us was the diagram. And in the diagram, I'm given that the measure of angle 1 is equal to the measure of angle 3, because it's got the congruency marks. So let's set up the two columns, statements and reasons. So my given is what was in the diagram. The measure of angle 1 equals the measure of angle 3. And that was given to me. It was marked in the diagram. Whenever I ask you to write a proof, I will always, on a test or a quiz, I will always have it spelled out for you. I will tell you specifically. You won't have to look at a picture and figure out what are you seeing. Now, when you're doing these geometry proofs, what we need to do is take a peek at what we're trying to prove. So somewhere in the body of my proof, I need to bring in these letters, DBA and EBC. And what you're going to be doing is reaching back to all of the chapters we've learned prior to when you're writing these proofs. And those are going to be legitimate statements that you can come up with by using definitions, theorems, postulates, whatever we learn. So in order to get DBA into my proof here, I'm going to use my angle addition postulate and show how angle DBA is made up of. And the measure of angle DBA is made up of adding angle 1, angle 2, and angle 3. So angle 3 plus angle 2 make up DBA. And the reason why I can state this is I'm using my angle addition postulate. I like to abbreviate this as AAP. We're going to be using these postulates a lot, so that's why I came up with an acronym. Next, what I'm going to do is I'm going to do substitution, the property we just learned. Because if you remember, up here, the measure of angle 1 equals the measure of angle 3. So I'm going to take out 3 and I'm going to replace it with angle 1. And that's my next statement, using substitution. The measure of DBA is equal to now the measure of angle 1 plus the measure of angle 2. And this was substitution, because I replaced 3 with 1. Now, notice I haven't gotten EBC in here, so that's what I'm going to show next. And remember, EBC was what I outlined in red, so I can now bring in that angle 1 plus angle 2 equals the measure of EBC. And now what I can do is, because this is the same as this, I can use my transitive property. This overlap cancels, and since they both equal the same thing, I can now say that the measure of DBA equals the measure of EBC by using my transitive property. Oh, I forgot a step here. This is 4. This was AAP again. And then 5 is transitive. Now, technically on the test, you could also tell me it was substitution. But on big ideas, transitive is going to be the better option that they'll be looking for. And that's a little introduction into what you're going to see coming up in the next 2 sections. It's not in tonight's homework.